So we'll get started. I want to start by saying, we're going to cover a few new features here in Adams 2018.1. So we've had a beta period for this for some time now, and it's now going to be going to final general release here in the next, say, 1 to 2 weeks. And so we'll be touching on a number of new features here that I show in the table of contents here through our real-time animation, car plant for VTD, some enhancements across Adams View and the other products, as well as plugging into a new MSC co-simulation framework. So let's talk through each one of these. First, we'll start with Adams real-time animation. So in about Adams 2017.1, in that release, we introduced Adams real-time, which allowed us to take Adams models through the FMI interface and bring them, complete Adams models and bring them over to a real-time operating system environment. Right now, that's our concurrent simulation workbench environment that we support and that we partner with Concurrent on. And this allows us to take Adams models as they are and move them and even modify them in the real-time environment for doing software in the loop at real-time speeds, hardware in the loop, driver in the loop type things. However, up until this release, one was not able to visualize the Adams model in terms of an animation. It was simply gauges and curves that you could do within the simulation workbench environment to kind of get an idea and a picture of what's happening with the model and the key output parameters of that model. So with this release, we're introducing the ability to animate Adams car models during the real-time simulations. And so this is really a switch you set when you export the FMU from Adams to send the Adams model over to the simulation workbench environment, where you can opt to turn this on there, and then the Adams real-time animator is launched. And it's a rather basic animation, the car on a grid road like you see driving around down here below, but enough to sense turning and turning, acceleration, deceleration, these kinds of things, and to get an idea of what's happening with the vehicle from an animation standpoint, as well as a result channel standpoint and behavior with the coupled hardware. So this animation does work on the same machine, or you can move it onto a different machine other than the one that Adam Solver is using during the real-time analysis, and this animation is limited to working on Linux platforms only right now at this point. So an exciting new feature for users of Adams real-time. Also in the Adams car world, we have a new feature this release called Adams Car Plant for VTD. So what is VTD? Some of you may not be familiar. About a year and a half ago, this last June 2017, MSC acquired a company called VRes. And VRes makes, among other things, a product called Virtual Test Drive, VTD. And Virtual Test Drive is used for development, test, and presentation of driver assistance and active safety systems. You get these very beautiful and high-detailed environments and with traffic and pedestrians and buildings and sensors on the vehicle to do all the kinds of driver assistance and active safety system studies that one might want to do in a very highly rich, detailed environment. What is new in this release is that an Adams car model can now be used as the physics behind the vehicle model in the VTD environment, as opposed to a simpler model that was that could be previously and alternately used within VTD. So this starts within Adams 2018.1 that we can export the plant, as we call it, from Adams to drive the vehicle in VTD. To represent the vehicle in VTD, we should say, and then VTD version 2.1 and later they're able to are able to accept those versions. So the bonus here is you're getting a higher fidelity model. You're getting this high fidelity Adams vehicle model and having it in detailed VTD environments. And the way this works is that, as I was careful with my words there in the last slide, is that VTD is driving the model, so the driver signals are passed to the Adams car solver. Throttle, brake, steering, these kinds of signals are derived either through VTD scripted driver controls, file-based, pre-planned driver controls, or a true hardware in the loop, driver in the loop scenario, like you see in the movie here on the right side of the screen. So those things are getting passed to the Adams car solver, and then Adams is returning the states of the vehicle body and the wheels back to VTD to position where the car is in the environment. So very exciting new feature, and looking really forward to especially our users of VTD already out there that they're interested in doing this, and hopefully a number of folks get interested in using their Adams car models within the VTD environment this way. Moving on to new features in other products, number of small enhancements made in Adams View this release. We are allowing vector math functions in the function builder, so some math functions have been available in the solver, as well as vector entry options in forces and torques, like the G-force, V-force, V-torque. These items have allowed vector entry as opposed to component-by-component entry in Adams Solver for a while. The GUI, catching up the GUI to that right here in this release, so that you could, instead of having to specify X, Y, Z components all the time for a general force or V-force, V-torque, as I say, you can specify magnitude of that and then use the vector math functions to define orientation of that vector. Also within Adams View, we've added to the solver settings dialog a GUI for specifying advanced solver settings. What's an advanced solver setting? They all seem pretty advanced to me, at least sometimes they do. And actually what we mean here are things that would populate the environment statement in the ADM file. That means things that folks maybe commonly refer to as environment variables. So ones that are legal in an ADM file environment statement, so things that would influence the running of the solver, the core basic Adams solver, things that would influence that during runtime. Those kinds of settings, environment variables, can now be populated into the ADM file through this GUI. So really what it does is it allows your advanced settings to travel with your models in CMD, also in, of course, ADM format. And so this is useful if you're sharing models with other folks, if you are running models on other environments, on other compute machines, and you're used to having your settings on your machine. Well, make sure they travel with your model this way and that way. You can put these on the compute machine settings. You can even override compute machine settings as well by switching things off. If you're afraid that your neighbor's computer that you're solving this on always has certain things set in the OS or even in the shells, you can deactivate those with this setting here in the ADM file. Again, facilitated through this new section in the solver settings GUI in Adams View. Also in Adams View, CAD interoperability version support has been updated. So the component we use for importing all the various CAD formats you see here has been updated, and that means the ones highlighted this release, the ones highlighted in red, now support one or two newer versions. So for instance, CATIA V5 you can see is up to R28 now. The Pro Engineer family is now up to Creo 5.0 for import, and so forth. You can see here on the slide. A number of other updates across the product line. Within Adams Solver, there have been, again, this release, same as the last, at least one, maybe two releases, some more performance improvements related to constraints. Covering, finishing a lot of work in terms of improving the performance and constraints in this release. So universal joints, hook joints, cylindrical joints, and all of the joint primitives are now showing performance gains. We've seen performance gains around 5 or 15% if you're looking at models that have significant amount of content in these object types and don't have significant content in other, huge let's say compute-thirsty components like flexible bodies and contacts and things like that. This benefit can be experienced with any Adams Solver integrator types, but we've seen it especially so with GStiff SI2. Also with Adams Solver, in terms of performance, the SMP, shared memory parallel performance, running on a multi-threads, that means. Here, Adams Solver's jobs now running with multiple threads will show improved solve times for models that contain diff statements. And so the diff statement now supports SMP. Prior to that, it was not thread safe, so you weren't getting multi-threading benefits on your diff statements. And Atom Solver results generation's also been improved for running on multiple threads. The larger the number of results that's generated by a given model, generally speaking, the greater the performance improvements will be noticed in this release relative to prior releases. Within the still relatively new Atom's drill product, we've added a more compliant motor component. So the bend angle and a bent push motor was previously enforced with a motion constraint on a revolute joint. In Atom's Drill 2018.1 now, this motion constraint's been replaced with a rotational spring damper, and those characteristics are automatically determined by geometry and material properties specified for the motor component. And this compliance in the motor model results in more accurate bending loads throughout the strings. It's not really just related to generating better results right on output channels coming from the motor, but it really provides more accurate loading results throughout the drill string. In Atom's machinery, in the gear module, planetary gear creation has been enhanced to support 6 planets, up from 5 in previous releases. Other news, the Atom's tire module has a faster high-performance mode for PAC 2002 tires. So that means when employing the high-performance mode for PAC 2002, it's higher performance even. So performance gains are observed relative to prior releases of Atoms. And specifically, you could say we've noticed, some measurements here that reasonably efficiently modeled, rigid body, full vehicle models, doing handling events, and running fixed step integrator for real-time analyses have been observed to go about 5 to 10% faster. But it is a general improvement, so it doesn't necessarily have to be limited to real-time applications. The gain here is really due to deactivating the tire general state equations, GSEs as you may know them, during dynamic analyses. And so this can be done manually through the command language, through the part create or part modify equation, general state equation command, which has been extended with a new statics only argument that you can flip on and off. Also within Atom's View, we've removed, just a note that we've removed the Hoops graphics driver option for the graphics windows. We removed it from the, really wasn't an option, but it was we replaced it with the, in the 2018.0 release for 2D charting and 3D charting in the Atom's post processor. This is just a removal of it here in the graphics window. So the OpenGL option, which has been the default for many years, more performant option anyhow, still persists. One other topic, a new feature topic to discuss, is the MSC CoSim product. So later this year, the MSC CoSim framework for co-simulation is a new product. It'll be coming out from MSC. It's currently in beta testing right now. And in its debut release this year, it will support 3 MSC products, Mark, SC Flow, and Atoms, starting with Atoms 2018.1. So this will allow co-simulation or tri-simulation, as you may want to call it, if we're talking about all 3 working together between these products. So if you are, if you're users of, say, doing Atoms Mark co-simulation today through the ACSI, the Atoms co-simulation interface, doing Atoms Mark co-simulations there, that product isn't going anywhere. That feature isn't going anywhere within Atoms until MSC CoSim is really a complete superset, including its capabilities to do things with some of the other partner products that ACSI works with as well. So that will still carry on, but under the covers, Atoms and Mark, fundamentally the CoSim that's going on here with the MSC CoSim is very, very similar to what we've got in ACSI today. But here we have the added advantage of now being able to plug into SC Flow for CFD solutions, and as you can imagine, as we move on over the next few years, the MSC CoSim product will allow us to plug in with other MSC products as well. So just giving us more and more options for co-simulating Atoms models with other models and doing some really interesting analyses and solving some tough problems that way. Lastly, I will touch on platform support for Adams 2018.1. There's no change relative to 2018.0, so still supporting Windows 7, Windows 10, and Red Hat Linux 6.7, 7.1, and 7.3, as well as SUSE 11, SP4, and SUSE 12, SP1. So no change in platform support relative to the 2018.0 release here. And before I turn it over to Yijin, once again, I'll say thanks to folks for tuning in, and thanks for beta testing. We've had a good beta testing this release cycle, and the commercial release again for Adams 2018.1 coming out here within the next 1 to 2 weeks.